Good morning. Welcome to Algebra class. The topic for this week, properties of logarithms. Textbook pages 462 to 468. Before we start, I want you to prepare the following: your algebra textbook, your pen, and your copybook. Before we start, I want you to watch this video.
What is the product property of logarithms? To see this property, remember that logarithms are just another way to write exponents. And it turns out that the properties of exponents apply to logarithms in some really cool ways. So to see this property, let's do a little exploring. Let's take two logarithms and add them together and see what happens. So let's say that we have this, log base 10 of 10 plus log base 10 of 100. Now to help us add these logarithms together, let's recall what we know about logs and exponents. Well, if we have this, log base a of b, and we set that equal to x, we can rewrite it like this. A to the x power is equal to b. So we can take something in logarithmic form and change it into exponential form. Let's do exactly that to help us solve this problem. So let's turn each of these logs individually into exponential form and then solve them. Then we'll bring them back together. So first let's focus on this logarithm. Log base 10 of 10. Since we don't know what that's equal to right now, we'll set it equal to x. Now let's turn it into exponential form. Doing that, we get 10 to the x power equals 10. In order to solve this problem, we need to find the value for x that makes this statement true. Turns out that value is 1. So that means that log base 10 of 10 is equal to 1. Because remember, that's what x is equal to, our original log. So now that we've solved this logarithm, let's focus on our other one. Log base 10 of 100. Since we don't know what this is equal to yet, we'll set it equal to y. Then let's turn it into exponential form. We get 10 to the y power equals 100. Solving, we get that y is equal to 2. Since y is equal to our original log, that means that log base 10 of 100 is equal to 2. So now we know what each of our logarithms is equal to. So let's take those values and add them together to find our sum. Here we have 1, and here we have 2. So in order to add these logarithms together, we just need to take 1 plus 2. And 1 plus 2 is 3. So that means that the sum of these two logarithms is 3. Neat. But let's play around a little bit more. Let's take one more logarithm and see what happens with it. Let's say we take log base 10 of 1000. We'll set that equal to z for now. Now let's change it into exponential form, so we have 10 to the z power equals 1000. That means that z is equal to 3. And that means that log base 10 of 1000 is equal to 3. This log is equal to 3. That's the same as the sum of these two logarithms. So we can say that log base 10 of 10 plus log base 10 of 100 is equal to log base 10 of 1000. And there's another way we could write this. We could also rewrite this as log base 10 of 10 times 100, since 10 times 100 is 1000. And look at what we have. Here, we take these two logarithms that have the same base and we add them together. To do that, we can simply take log of the product of 10 times 100. And it turns out that this property works in general. Here we have actually seen the product property of logarithms in action. So let's take a look at it. This property states that for positive numbers b, m, and n, with b not equal to 1, log base b of m plus log base b of n is equal to log base b of m times n. Here we have the product property of logarithms. And notice, in order to use this property, we need to be adding together logarithms that have the same base. But why does this work? How do we know that this property is true? Well, to figure that out, let's play around with the property a little bit. Let's take a look at each of these logarithms individually and use our knowledge about logs and exponents. So let's take a look at that first logarithm, log base b of m. Let's set that log equal to x. Now let's change this from logarithmic form to exponential form. Doing that, we get b to the x power equals m. Now let's take a look at this logarithm. We have log base b of n. Let's set that equal to y. Turning that into exponential form, we have b to the y power equals n. Finally, we'll take a look at this logarithm. We have log base b of m times n. We'll set that equal to z. Changing that into exponential form, we get b to the z power equals m times n. Great. Now, let's try to find m times n. Well, here's what m is equal to, and here's what n is equal to. So if we want to take m times n, we could take b to the x power times b to the y power, since this is m and this is n. So we would get m times n. But notice, m times n is also b to the z power. So all of these things are equal. And take a look here. We're multiplying together two things with like bases. The product rule of exponents states that we can leave that base and add the exponents. So now we have that b to the x plus y power is equal to b to the z power. Here we have the same bases, and these two things are equal, which means that their exponents need to be equal as well. So we have x plus y equals z. Now what were x, y, and z? Well, here we have x, here we have y, and here we have z. Let's plug them back in. X is equal to this log, log base b of m. Y is equal to log base b of n. And z is equal to log base b of m times n. And look at what we have. This is the product property of logarithms. We just found this property by using our knowledge of logarithms and exponents and the exponential rules that we know. So now here we have the product property of logarithms.
In this problem, you will simplify logarithms. What is the expression written as a single logarithm? Part A. Log base 4 of 32 minus log base 4 of 2. Use the quotient property of logarithms to rewrite the expression. Remember, the quotient property of logarithms says that a logarithm in the form log base b of m minus log base b of n is equal to log base b of m divided by n. For this expression, use 4 for b, 32 for m, and 2 for n. Divide 32 by 2. The logarithm is base 4, so rewrite 16 as a power of 4. Simplify. So, the expression is equal to 2. Part B. What is the expression 6 times log base 2 of x plus 5 times log base 2 of y written as a single logarithm? What must you do with the numbers that multiply the logarithms? Apply the power property of logarithms. Use the power property of logarithms to rewrite the expression. Next, use the product property of logarithms. Remember, the product property of logarithms is log base b of m plus log base b of n equals log base b of m times n. So, the original expression is equal to log base 2 of x to the 6th power times y to the 5th power. Expand logarithms. What is the logarithm expanded? Part A. The first logarithm is log of 4 times x divided by y. Use the quotient property of logarithms to rewrite the expression. Remember, the quotient property of logarithms says that a logarithm in the form log base b of m over n is equal to log base b of m minus log base b of n. Substitute the values for m and n. Now, use the product property of logarithms to expand log of 4 times x. Remember, the product property of logarithms says that a logarithm in the form log base b of m times n is equal to log base b of m plus log base b of n. The expanded logarithm of log of 4 times x divided by y is log of 4 plus log of x minus log of y. Part B. What is log base 9 of x to the 4th power divided by 729 written in expanded form? Can you apply the power property of logarithms first? No. In the expression, the 4th power applies only to x. Use the quotient property of logarithms to rewrite the expression. Next, use the power property of logarithms. Write 729 as a power of 9. Simplify. The expanded form is 4 times log base 9 of x minus 3. In this problem, you will use the change of base formula to simplify expressions. Part A. What is the value of log base 81 of 27? There are 2 methods you can use. Method 1. Use a common base. What common base has powers that equal 27 and 81? 3 is a common base. 3 cubed equals 27, and 3 to the 4th power equals 81. Use the change of base formula. Now substitute the values in the equivalent expression. Remember, 3 is a common base of 27 and 81. Now simplify. So the value of log base 81 of 27 is 3/4. You can also use the change of base formula with base 10 logarithms. Method 2. Use a calculator and base 10. Now substitute the values in the equivalent expression. Since the logarithms are base 10, the base does not need to be shown. Now use a calculator to simplify. Using method 2, the result is the same as in method 1, 3/4 or 75/100. Part B. What is the value of the expression log base 5 of 36? Write the original expression. There is no common base for 36 and 5. Use the change of base formula and base 10. What would be a reasonable result? 5 squared equals 25, and 5 cubed equals 125, so log base 5 of 36 should be between 2 and 3. Use a calculator to evaluate. So, the value of log base 5 of 36 is approximately equal to 2 and 23/100ths.
When love comes in, ooh la la la. Love comes in, ooh la la la.
In this problem, you will use a logarithmic scale to solve a problem. The pH of a substance is the negative logarithm of the concentration of hydrogen ions. The concentration of hydrogen ions for the household ammonia is 10 to the negative 11th power. The concentration of hydrogen ions for vinegar is 6 3/10 times 10 to the negative 3rd power. What is the difference of the pH levels of ammonia and vinegar?
Thank you for listening. If you have questions, just send your message through Schoology. Have a great day.